Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we'll continue our discussion, or we call our lecture 3 or 4, topics 2, equations, inequalities, and absolute values, with a subtopic of 2.2, inequalities. So before we continue, okay, sorry, I have no idea on how the other, YouTubers making all this sign of subscribe, share, like, and also click the bell button here. Okay, so if you don't mind, I do hope that all of you willing to click on the subscribe button, like, share, and the bell here to support my channel. Okay, so without wasting so much time, today we are going to look at learning objective for this subtopic, to find the rational inequalities involving linear expression. Okay, rational means that we have as in the form of fx divided by gx. Okay, rational inequalities involve what we call the sign of greater than or equal, less than or equal, and linear with the ax plus b. Okay. Rational inequalities can be expressed in the form of this, as you see on the screen here now. Okay, so I do hope that all of you refer to your lecture notes when we all this stated in your notes then. Okay, so these are example of rational inequalities that involve with we call a linear function. Okay, so in rational we have fx divided by gx, inequality sign here, and also this is linear, 3x plus 1 and x minus 5, and another one here, two rationals on the left and right side of this sign of greater than. Okay, so to solve ratio inequalities, cross multiplication. So please take note with this one here. Cross multiplication must be avoided. Okay, because this method would lead to inaccurate solution, except for qx. Qx means that bx divided by qx. Okay, the denominator, which values is always positive. If qx with the values is always positive, then we are allowed to come up with this method of cross multiplication. So the most reliable method is to collect all the terms on one side of an inequality. Okay, what's the meaning of this statement here? Example. Okay. Okay, solve these inequalities. Okay, sorry, I have something wrong with this. Okay, it's happened again. Okay, sometimes this old pen and the wizard code have a problem. Sorry for that. Okay, so for this one here now, we got x plus 1 divided by x minus 1 greater than 0. Okay, so we assume let x plus 1 greater than 0, x minus 1 greater than 0, then x greater than negative 1, and x greater than 1. Okay, on one number line, here, x, okay, we have n negative 1 and 1. So both greater than. Okay, class, the previous lecture notes or videos, I come up with a term of n. And when there's a term of n, we have one solution on the left side, right side, and one solution on the other side, right side. And then with those solution of case number 1 and case number 2, we combine, put them all together, and find where do we call the both solution intersect each other. Okay, but for this case, do you find any term of n or O in this statement or question here? Do you find any term of n or O? No, right? Okay, there's no term of n or O here. Okay, means that for this question, for this solution, we are not going to play with where these two lines intersect each other. No. Okay, for this one, let's imagine that we divide it into 3 sections. Okay, so where in this section where we find that there is a line of this, then we assume and we take this is a positive, positive, negative, positive, negative, and negative. Okay, so then negative. Okay, just imagine that if there is a value of x in between here, 0, here negative 2, and here 2. Okay, I'm just explaining you why we have this sign of negative and positive, but you don't need to show this in examination, just for your knowledge. Okay, when x negative 2, negative 2 plus 1 equal to negative 1. Negative 2 minus 1 equal to negative 1. Yes, negative value, negative value. So negative value divided by negative value, positive. Okay. Just like this box of divide. Okay. Positive, negative, positive, negative. Okay. Positive value divide by positive value, positive. Positive value divide by negative value, negative value. Okay. Negative value divide by positive value, just like negative 2 divided by 3 equal to negative 2 over 3, right? Okay, negative, and negative value divided by negative value, negative 2 divided by negative 4 equal to 1 over 2, positive, am I right? So it is positive here. Okay, so then if substitute x with 0, because 0 lies in between negative 1 and 1. 0, 0 plus 1, 1, positive. 0 minus 1, negative. So there's a 1 sign with positive and 1 with negative. So negative divided by positive, negative. And of course positive divided by positive, positive. And then refer to the whole function of px divided by qx, a rational function here. It is greater than 0. The numbers that greater than 0 are all positive, am I right? Okay, so we are referring to this section and this section. So the final answer for this is negative infinity until negative 1 union 1 to positive infinity. Okay, in interval form. So in solution set, you just write down, okay, write down where x in bracket of x element of real numbers and where x is less than negative 1 or x greater than 1. Okay. Either one is either this method or in this form or this form, is all up to you then. Okay. Solve this inequality. Okay. In the first statement of solving this, we are not allowed to come up with the method of cross multiplication, where multiply with x plus 1 here and multiply with x plus 1 here on the right side. No, because unless if the qx, the denominator, is positive. For x plus 1, it can be positive or it can be negative. So we are not allowed to do what we call cross multiply it for this one here. So what can we do here now is we are going to bring these two to the left side. 3x plus 5 divided by x plus 1. Positive 2 bring the side become negative, so minus 2 less than 0. Okay, this is in rational form. Okay, we have numerator and denominator, and this is a real numbers too. So we just assume that it's just something like 2 divided by 1, which is equal to 2. Okay, we cannot combine these two transform them into one rational function. No. Okay, because this we call irrational with a denominator of x plus 1, and for this one here, denominator is 1. We can only combine them if we can make some changes. Make sure that the denominator for this part here is equal with this one, x plus 1. So I'm going to multiply with this x plus 1 and also x plus 1. So multiplication. Okay, these two, 2 multiplied with x plus 1 divided by x plus 1. So now both are in fraction and both with an equal denominator of x plus 1 and x plus 1. Now 3x plus 5 negative 2 times x minus 2x, negative 2 times 1 minus 2 divided by x plus 1, which is less than 0. Okay, 3x minus 2x, x. 5 minus 2, 3 divided by x plus 1, less than 0. Okay, so now we got x plus 3 greater than 0. Let both of these to greater than 0 and x plus 1 greater than 0. Okay, the previous example, we got this one is greater than. Okay, the previous slide, we can see here clearly that it is greater than 0. Okay, and then we just use the term of let or assume. Okay, andaikan. Assume that these two linear is greater than 0. Just assume it. Don't bother about whether it's a positive or greater than or less than. Let it be. Okay. So we assume or let these two greater than 0. Then with x greater than negative 3 and x greater than negative 1. Okay. So we got negative 3 and 1. And again, do you find any term of n or in between these two? No. Okay. So clearly, we are not going to play with the sign. We call the term of intersection, but then we are going to come up with the sign of negative and positive. Okay, so this, x plus 3 divided by, so negative divided by negative, positive. Negative divided by positive, negative. Positive divided by positive, positive. Okay, let's get back to the original question here. 3x plus 5 divided by x plus 1 less than 2, or look at this one here, x plus 3 divided by x plus 1 less than 0. The numbers that less than 0 are all negative, right? Negative, so we're taking this symbol. So with the final answer, final solution here, we call the solution set for this in interval form here is negative 3 until 1. Okay, now 2x plus 3 divided by x minus 1 less than or equal with 2x minus 1 divided by x plus 3. Okay, the whole of this rational function here for the numbers here or fraction we bring to the other side. Okay, where 2x plus 3 divided by x minus 1 and minus 2x minus 1 divided by x plus 3. Okay, now both in fraction, but right now what we have here right now is denominator of these two are not equal. This one is x minus 1 and this is x plus 3. So we cannot simply make an operation between these two unless if we can come out with the result of these two fractions with the equal denominator. We equalize the denominator. Okay, so what I'm going to do next is 2x plus 3 divided by x minus 1 multiplied with x plus 3 divided by x plus 3 minus 2x minus 1 divided by x plus 3 multiplied with, denominator of this, x minus 1 divided by x minus 1 less than or equal to 0. Okay. What can you see here now? Okay, so these two, x minus 1 multiplied with x plus 3, x plus 3 multiplied with x minus 1. Multiplication of these two will come up with 1 of x minus 1 and x plus 3. So on the top of numerator here, multiply 1 by 1. 2x multiplied with x, 2x squared. 2x times 3 equal to 6x. 3 times x equal to 3x. 3 times 3 equal to 9. Minus 2x times x, 2x squared. 2x times x, 2x squared, multiplied with negative, minus 2x squared. 2x times negative 1, negative 2x, multiplied with negative, become positive 2x. Negative 1 times x equal to negative x. Negative x multiplied with negative equal to positive x. Negative 1 times negative 1, 1. And 1 multiplied with negative, minus 1. Less than or equal to 0. Okay, so I'm going to simplify this first before we move to the next line, which I think that is not much space to solve this one here. Okay, 2x minus 2x. Okay, 6x plus 3x equal to 9x. 2x plus x equal to 3x. 9 minus 1 equal to 28. So I can see now 9x. Okay, 9 plus 3 equal to 12x. 9 minus 1 equal to 8 plus 8 divided by x minus 1 and x plus 3 less than or equal to 0. Okay. 12x minus 8 or 12x plus 8 divided by x minus 1 and x plus 3. X minus 1 and x plus 3 less than or equal to 0. Okay, so now, as I said just now, there is no term of n or o from the beginning of the question, step 1, step 2, step 3, step 4. There is no term of n or o in this solution here now. So then, we just assume that this, and this are all greater than 0. Class, the first example, the whole rational is greater than 0 only, greater than only. The second example, you come up with less than only. Now, be careful, it has less than or equal. Okay, 0 over 10 questions equal to 0. I give you 10 questions of quiz questions for you to answer and you get it all incorrect, means that 0 over 10 equal to 0. Am I right? Meaning the numerator can be equal to 0. But what about if you get 10 marks, 10 questions correct out of 0 questions? You answer all 10 questions correct, but I didn't give you any quiz question at all, but you get all 10 corrects. Is that logic? Meaning the denominator cannot be equal to 0. Okay, so the denominator on this question here right now is x minus 1 and x plus 3. So look at this one carefully, less than or equal. So let 12x plus 8 greater than or equal to 0. X minus 1 greater than 0. And x plus 3 greater than 0. Okay. So then, okay, look at this one here now. Greater than or equal, because we assume everything is positive, except for this one is greater than or equal. This one greater than only, greater than only. So 12x greater than equal to negative 8, then x greater than equal. Okay, we divide these inequalities with positive value of 12, not negative 8. So 12 divided by 12, negative 8 divided by 12, positive. So the direction of this remain. Negative 8 divided by 12, negative 2 over 3. X greater than 1, x greater than negative 3. Okay, negative 3, of course, the smallest value among these, negative 3, 1 and negative 2 over 3. Negative 2 over 3 is negative 0.6666. So negative 2 over 3 and 1. Okay, look at the direction of these three is all greater than, and this one here is greater than or equal. Greater than. And greater than. Okay. So we got here is negative, 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 positive, negative, negative, positive, negative, positive, 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 positive. Okay, so divide or multiply is all the same for both of multiplication and divide. Okay, just like this one here, multiply the negative, multiply with negative, positive, divide by negative, negative, and this one give positive, negative, positive. And refer to this question back here again, the whole rational function here is less than or equal. Less than means a negative value, because negative value is always less than 0. So which section or area that we're looking for? This one here and this one here. Okay, so our final solution set for this is negative infinity until negative 3 union negative 2 over 3 equal here negative 2 over 3 and positive infinity. Okay. Okay, now for this one just like in we call the previous videos, we are going to separate this into two parts. The first is Okay, look at this one here now. X divided by x minus 1 greater than or equal to negative 1. X divided by x minus 1 greater than or equal to negative 1. X divided by x minus 1 less than or equal to 4. Okay, in this form, yes, we are going to come out with a term in between this and this, which is the term of n. Okay, so when it comes to the term of n, when we solve this part, we got one solution. And we solve this part, we got another solution. The solution of case number 1 and case number 2, we combine them all together and we are referring to this term of n, which is intersection. Okay, let's try. Okay, for case number 1, and this is case number 2. Case number 1, we bring this to the left side. X divided by x minus 1, negative 1, bring here become positive, positive 1. Okay, I straightly multiply with the denominator of this with x minus 1 divided by x minus 1 greater than or equal to 0. Okay, so right now both this rational recall have an equal denominator of x minus 1 and x minus 1. So x plus, okay, 1 times x and 1 times negative 1. So we got x plus x minus 1 divided by x minus 1 greater than or equal to 0. X plus x, 2x minus 1 divided by x minus 1 greater than or equal to 0. What about this one here now? Okay, bring this 4 to the left side. Then we get x divided by x minus 1, positive 4, bring here become negative, minus 4 times x minus 1 divided by x minus 1 less than or equal to 0. Okay, and again we have equalized the denominator for these two, left and right, so we can just simply, so we call make operation, expand this one here, x minus 4 times x minus 4x, negative and negative positive, 4 times 1 equal to 4 divided by x minus 1 less than or equal to 0. So x minus 4x, negative 3x plus 4 divided by x minus 1 less than or equal to 0. Okay, and then let these two, 2x minus 1 greater than 0 and x minus 1 greater than 0. So then 2x, okay, x greater than 1 here become positive, so divide by 2, x greater than 1 over 2 and x greater than 1. Okay, for this one here now, negative 3x plus 4, okay, assume with this great, okay, class, this is greater than or equal, so the numerator will come out with equal sign, but not for denominator. X minus 1 is greater than only, so this is less than or equal, so we assume these two positive, which is greater than or equal to 0, but not for x minus 1. X minus 1 greater than 0 only. Okay, so then negative 4 bring here become positive, positive 4 bring here become negative 4. Negative 4 divide by negative, then this direction change. So you come out with x less than or equal to negative 4 divided by negative 3, 4 over 3, and x greater than 1. Okay, I think that we need to move to the other slide. X greater than half, x greater than 1. Okay, case number 1 and case number 2. Just now, x greater than half, x greater than 1, x greater than half, and x greater than 1. x less than or equal to 4 over 3, x is less than or equal to 4 over 3, and x greater than 1. For this one, greater than. Okay, so greater than, equal to, greater than, or equal. That's it. Okay, so now let's solve the first part here. Don't forget that we have the term of n in between case 1 and case 2. Here, we call there's we call the term of n in between case number 1 and case number 2. Okay, so we solve the first part here. 1 over 2 1 over 2 and 1. 1 is greater than or equal, and the other one is greater than. Okay, so we got here is positive, negative, positive. So the final solution, okay, 2x minus 1 divided by x minus 1. 2x minus 1 divided by x minus 1 greater than or equal to 0. And here is negative 3x plus 4. Negative 3x plus 4 divided by x minus 1. X minus 1 less than or equal to 0. Okay, I'm now copying out this part and this part. Less than 0. Less than or equal to 0. Okay. So now, we got positive and positive, negative, positive, negative, negative. So, positive, negative, positive. But then, which section that we're going to choose then? Refer to this. It is greater than or equal is for positive. So, take this and this. So, the final, so the solution set for case number 1 here is negative infinity until 1 over 2 union 1 to positive infinity. This is not the final answer yet. This is just solution for case number 1. And case number 2, 1 and 4 over 3, which is 1 is less than or equal to 4 over 3, and the other one here is greater than 1. Okay, so we got here now is positive, negative, positive, positive, negative, positive. So, multiply, divide by positive and negative between these two, it gives you negative, positive, and negative. So, the whole fraction here is less than or equal. Less than is negative value. So, take this one here now and this. So, the solution set for case number 2 from negative infinity until 1 union 4 over 3 to positive infinity. Okay, right now we're almost at the end of the solution here. Take this and this one. This is the solution for case number 1 and this solution of case number 2. Between case 1 and case 2, we are going to combine them together, bring these two solutions into one number line, and we are going to finalize to find out where these two solutions intersect each other. Okay, so bring this here and also here. So what we have here right now, 1 over 2 and 1. 1 over 2, 1, and 4 over 3. Okay, so solution of case number 1, I'm going to use the red ink. So then, from negative infinity until 1 over 2. And then 1 to positive infinity. The other one, the one with the which I put in a box we call of purple here. So I come up with this we call purple ink from negative infinity until 1. From negative, okay, from 1 negative infinity until 1. So 1 to negative infinity, and 4/3 to positive infinity. So we are going to finalize by referring to this term, and N means that where do the line of purple and red intersect each other. Here, no. Here, no. Here, yes. And here, yes. So then, let's finalize to end our discussion for this part. It is from negative infinity until half. Union, okay, this one here, 4/3 to positive infinity. There you go. Okay, so that's all for today for this lection of part 3 for chapter 2. And I do hope that all of you understood, and you may continue with your tutorial work and past year questions to strengthen your skills. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.